a spherical balloon is being inflated such that its volume increases at a constant rate of 100 centimeter cube per second. At the instant the diameter of the balloon is 50 centimeter, at what rate is the radius increasing? So we have a balloon. So this is balloon. It is increasing the volume. It keep increasing. So the radius keep increasing. And in this case, it talk about the diameter, just 2 times the radius. So we have the formula to write down the volume. We can compute the volume in terms of the radius. The radius is increasing, the volume is increasing. And in this case, they said that the increasing rate, the volume is increasing at the constant rate. This one. So that means dV over dt. So over time, the rate that the volume is increasing is 100 centimeter cube per second. So that one is fixed. This one is always, at any time, is always 100. At the instant, the diameter of the balloon is 50 centimeters. So we have at one point, the diameter is 50 centimeters. And at that point, the radius, half of the diameter, 1/2, 50, which is 25 centimeters. We want to compute the rate. What rate is the radius increasing? So we want to compute d at this time, the particular time. This time the radius is 25. What is the rate? dr over dt. We need to compute that. So this is a question. They give us a balloon. It is increasing in volume. We know the rate of change dV over dt is 100. They ask us at the moment where the diameter is 50. We need to compute dr over dt. So we need to set up the relation between the two quantities here. So we have the volume and the radius. We know that for the spherical balloons here, we have the formulas volume equal to 4 divided by 3 pi radius cube. This is the formula we will use in this example. So the volume and the radius depends on time. Your time change, the volumes keep increasing, the radius increasing. So volume depends on the time t. The radius also depends on the time t. So now we need to compute dr over dt. We know already dv over dt. So what we will do is we do differentiating both sides. So let's do differentiating this equation. dv over dt equal to 4 over 3 pi. This term just constant, let's keep it there. Now we will change rule. Times 3 r square. I remove all t. So for make it simple, r square times r prime or dr over dt, because that's on the answer to compute. That's why I write dr over dt. This term is the term we need to compute, and the rest we know everything. You know dv over dt, which is 100. You know the radius, and therefore you can compute dr over dt. dr over dt, or to make it easy, I don't need to divide both sides by this. Let me compute, just put all the numbers here. 100 is dv over dt. 4 over 3 cancel out. So you have 4 pi r radius, we just talked about that. Radius is 25 at the moment, the diameter is 50. 25 square times the r over dt. So on the left you have 100, on the right you have 425 times 25 pi. I just split this into 25 times 25. This is 100 dr over dt. Here we have 100 on the left, 100 on the right. That gives us 1 equal to 25 pi dr over dt. So dr over dt is 1 over 25 pi. And this is the final answer.